All right, let's pull back the curtain on one of the most talked about and maybe most misunderstood technologies on the planet, ChatGPT. How does it really work?
You've been there, right? You type a question into that little box, hit enter, and poof, a detailed, coherent, and sometimes scarily creative answer just appears. It feels like magic. But what's actually happening in that tiny gap between you asking and it answering?
Okay, so this is going to sound almost ridiculously simple, but it's the absolute key to understanding everything else. For a minute, forget all the hype about a thinking machine. At its most basic, fundamental level, ChatGPT is a prediction engine, a super-powered autocomplete whose entire existence is focused on one single task, guessing the most likely next word. So let's talk about that prediction machine. How does it go from guessing one word to building the complex answers that we see? Well, it's not a single flash of insight. It's more like a builder laying bricks, one at a time. It all happens step by step. So you give it a prompt, like, the capital of France is. Based on the trillions of words it's read, it runs the numbers and calculates that the most probable next word is, of course, Paris. But it doesn't stop there. It then adds Paris to the sentence and asks itself, okay, what's the most likely word to come after the capital of France is Paris? And it just keeps doing that over and over and over, one word at a time, until it builds a complete thought. So how can it make predictions that are so smart? Well, the secret sauce is a piece of tech from 2017 called the Transformer architecture. This was a total game changer. Before the Transformer, AI was pretty good at spotting simple patterns. But this allowed it to understand the relationships between words and ideas, which is a whole different ballgame. Okay, so we know it predicts words, but here's the thing. Computers don't understand words, not like we do. They live in a world of numbers. So before anything else can happen, it has to translate our language into its language. And that translation happens in three main steps. First, your sentence gets chopped up into pieces called tokens. These can be whole words or sometimes just parts of words. Second, every single one of those tokens is assigned its own unique number. And third, this is where it gets really mind-bending, that number is converted into a huge list of other numbers, a set of coordinates called a meaning vector. The best way to picture it is like giving every word its own GPS location on a giant, multidimensional map of language. And what's so amazing about these vectors is that they actually capture meaning. On this giant map of language, words that mean similar things are placed right next to each other. So the coordinates for king are mathematically very close to the coordinates for queen, and dog is right next to puppy. This is how the AI starts to understand relationships, not by reading a dictionary, but just by seeing how close things are on the map. But that brings up a really common problem in language, right? Ambiguity. How does it know that when you say the word bank, you mean the side of a river and not the place you deposit a check? The answer is a brilliant part of the transformer called the attention mechanism. And you can think of it, well, exactly like a spotlight. As the AI reads through your sentence, this spotlight scans back and forth, highlighting the other words that are most important for understanding the current word it's looking at. So in our example, I walked along the riverbank. When the AI gets to the word bank, the attention mechanism shines a huge spotlight back on the word river. It knows that river is super important to understanding bank here, so it pretty much ignores the whole financial meaning of the word. And that's how it nails the context. So we have this incredible technology, but a brilliant machine with an empty brain is useless. It has to learn. And that's where we as humans come into the picture. The whole process starts with what's called pre-training. This is where the model is basically let loose on a massive, massive chunk of the internet. We're talking trillions of words. And by just doing that one simple task, predicting the next word over and over on this gigantic data set, it starts to absorb the rules of grammar, tons of facts about the world, and even the basics of how to reason. But there's a huge catch. Learning from the internet means you learn everything from the internet. The good, the bad, and the just plain wrong. A model trained only on this raw data would be a mess. Unhelpful, biased, and full of nonsense. So to fix this, they use a process called reinforcement learning from human feedback, or RLHF. Honestly, the best way to think about it is like training a puppy. First, human trainers have the AI generate a bunch of different answers to a prompt. Second, the humans rank those answers from the very best to the very worst. This teaches a separate reward model what humans actually like. Then, the main ChatGPT model is trained with one goal: to generate answers that get the highest possible reward score. It's literally being trained to be helpful and safe. So now we have this incredibly powerful, fine-tuned model. But, and this is a big but, it is not perfect, not by a long shot, and it's so important to understand its limitations. There are a few big ones to always keep in mind. First, hallucinations. It can just make stuff up and state it with absolute confidence. Second, it has a knowledge cutoff. It doesn't know about anything that's happened recently. Third, bias. It learned from the internet, so it can accidentally reproduce the biases found there. And finally, it has a limited memory. In a really long conversation, it can literally forget what you talked about at the beginning.
And this all comes back to that crucial point from the beginning. ChatGPT doesn't have a fact checker inside its brain. It's not looking things up. It is simply predicting the most statistically probable, plausible-sounding sequence of words to follow your prompt. And sometimes, what sounds most plausible just isn't true. Which leads us with the million-dollar question, doesn't it? The one that people in the field are still debating right now. When we see these incredible, articulate, and creative responses, are we witnessing a spark of genuine understanding? Or is it just the most sophisticated, most convincing act of pattern matching in human history? The truth is, we're still figuring that out.